Let's talk about piecewise functions. So in this video, we're going to do just this example you see on the screen here. We'll talk about plugging numbers into it one at a time, and then we'll take some time and actually graph it on the slide. All right, so a piecewise function, sometimes called a piecewise defined function, is like what you see here, where you have this kind of brace on the left side only, and then two or sometimes three or four or five different formulas for the same f of x that are assigned to different parts of the domain. So what's happening here is like it's all f of x. So when we graph it, it's just one graph. But if x is less than 2, then you're using this formula. And if x is greater than or equal to 2, you switch and use a different formula. Okay, so when we're plugging numbers into this piecewise function, it's kind of like a two-step process that regular function computations don't have. So f of -3, that means compute the y value when x is -3. So the first step of this process is to take this -3, so this means x is -3, and we want to decide which of these two domain pieces that number falls into. So is -3 less than 2, or is it greater than or equal to 2? And certainly it's the first one, right? So -3 is a number less than 2. So that means we're going to use this formula right here. So we'll have negative 3. So we get +3 as the output. Okay, we'll repeat the process for 0. Is 0 less than 2 or greater than or equal to 2? 0 is less than 2, so we're going to use this formula again. We get -0, which is just regular old 0. All right, f of 2 is really interesting because 2 actually is the break between these two formulas. But you'll notice exactly 2 is not strictly less than 2. It's actually greater than or equal to. So this function right here takes over. We say, oh, okay, 2 actually meets this description. So I'm going to use the 2x minus 1 formula now instead. So that's 4 minus 1 is 3. Finally, for f of 4, we'll do the two parts one last time. So is 4 less than 2 or greater than or equal to 2? I would say it's greater than or equal to 2. So it goes into this formula, and the negative x has nothing to do with this computation. So we'll have 2 times 4 minus 1. That's 8 minus 1 is 7. Okay, so that's how we plug numbers into our piecewise function. Worst case scenario, we have to actually graph it ourselves. And it's not just putting a few points and connecting them because we have this domain break. All right, so the first thing I do when I plot a piecewise function is I look for where the domain breaks are. And for us, it's just at 2. Sometimes you have like 3 or 4 formulas here, so it breaks in a couple places. But for us, it's just at x equals 2. So I'm actually going to draw in my picture, this isn't actually part of the graph, it's just a visual aid. I'm going to show myself where it switches from the line -x to the line 2x minus 1. So for x less than 2, that puts us over here. These are all the x's less than 2. Again, this isn't part of the graph. I'm just trying to organize stuff from my mind. So x less than 2, I'm going to use this formula. So I'm going to plot y equals -x. I'm just only going to show it to here, and then I'm going to assume on this dotted line that graph got cut, like literally cut off with scissors and tossed. And then on the other side, for x greater than or equal to 2, so that'll fill in the point at 2 and go this way, we'll use the other formula. So I like to do these little domain breaks kind of horizontally, either at the top or the bottom of my picture for these, or my graph, but they're not like a required official part of the graph. They just kind of help me keep my mind straight. Okay, so let's go from left to right. Y equals -x. This is a straight line, so technically, as soon as we have 2 points, we can plot it. We have computed a few points already. We know f of -3 is 3, and we know f of 0 is 0. Since -3 isn't, it's kind of beyond the scope of my picture, I could certainly just add it in, or I can just plug in points as needed, right? So it would be convenient to have a point at x equals 1 just to get me closer to the break. So I say, all right, well, if I plug 1 in here, I would get -1. So I know 1, -1 is on this. And then I also want to go all the way to the dotted line. So this is x strictly less than 2. So I'm going to plot this next point with an open circle, but I have to at least put that open circle there so it shows like kind of where the graph was supposed to be and make it clear that at 2, you jump to the other part of the graph. All right, so at 2, this should have or would have plotted at -2. So I'm going to put to -2 as an open circle, and then the graph stops here. So nothing over here is going to get graphed. It's just going to be regular, pretend that line came out straight, regular kind of straight line. It'll go forever in that direction, but then it stops at my open point. I'll do the other part of this graph in green just to match my organization, but remember, everything that's actually in the XY plane here is the graph. So it's all one function is what I mean. All right, so at x equals 2, we start using this formula, and we decided f of 2 was 3. So we've got 1, 2, 3. Solid point, because that point really is there. And then I just need one other point because this is a straight line. If we plug in 4, we get 7. I guess we have no choice but to go off the picture here. I'm gonna extend my axes a little bit. All right, 1, 2, 3. All right, so I can put 4, 7 way up here. And again, it's a straight line. I'll just go through my visual aid. So the actual graph of this piecewise function is all of this, and then all of this to the open point.